Okay, so today we're going to start with function notation. So what is function notation? Function notation really is a notation that allows us to work with multiple equations. Really, it's what it's really for, and you'll see in a little bit. We'll start off with one equation, just kind of explaining what you do with it. But function notation really allows us to work with multiple equations together, and that's what we're going to do here. So first things first, what is function notation? So it literally is about taking this y and saying it equals the 4x minus 1, and we convert it to this thing called function notation, which basically allows us to give a name other than y to an expression. So one of the most common ones you'll see is this f of x. So we'll write this as f, parentheses with an x, and we'll claim that this is equal to 4x minus 1. And now one of the most important things here I want to bring back to you is just, one of our basic properties here. And the transitive property, right? Like if y equals 4x minus 1 and f of x equals 4x minus 1, well then y, must be equal to this f of x notation that we're using, right? So the important thing here is that understanding that this entire piece here is what really is representing y, and remembering our notes from yesterday, y, is equal to the output. So the next thing we need to know, well, if y is equal to the output, then f of x must be also called the output, right? So just some general terminology that you're going to want to have under your belt. The other thing that we have here is that from the reflexive property, right, a number is always equal to itself. So if x equals x, all right, it means it doesn't change. So over here we had 4x minus 1. Well, over here it's 4x minus 1, but notice we now placed this x right here. So that x doesn't change. That x is still what it is before. So if x was the input, all right, a couple of things you need to know, that generally we said x was our input, it doesn't matter where we place, where that x is placed, it still represents the input. So what we're basically going to learn here is that this x in this function notation basically says I have an equation with this value of this input. And that's all function notation is, but it allows us to work with multiple equations at once, and that's kind of the purpose of it. So you've been hearing me say it, but this is read as f of x, So, and it's interpreted as being that this is the input, right? So basically the evaluation of a function with an input, So what we need to know here is that f, so f is the name of the function and x, is the input, all right? So if f is the name and x is the input, that's kind of what that's going at there, So for instance, function notation, let's evaluate these. Let's do some examples. And it's not a hard thing to do, We're still using substitution. So we're still using this idea that if A equals B, then wherever a and A is present, I can replace it with B, right? We're still using this principle of substitution. So for this example, I have f of x equals 4x minus 1. So it says find f of negative 7. So what it wants you to do here is it simply wants you to do the input. So all I'm doing is substituting, a negative 7. That's all I'm doing into this equation. So here we go. So f of negative 7 equals 4 times negative 7 minus 1. And then over here, I'm going to evaluate this, The left-hand side, this, remember, is y. So this is really like saying y equals. So over here, all right, I'm going to say that f, so I'm going to take my work over here, f of negative 7, y, okay, is equal to, well, 4 times negative 7 is negative 28, and negative 28 minus 1 is negative 29. And that's where we end up with a final answer. You don't have to do anything with this f. This is not f times negative 7, right? So it's just function notation. So it's important that you don't think you're solving for f. F is the name of the equation. All right, again, so to kind of help you understand kind of what we're doing here, okay, I'm going to use the transitive property over to the right again, right? So what we have here is, what we're dealing with is something that is being an input, right? Like in the problem that I just did here, all right, so the f of x, okay, so what we're trying to find here, if f of x, okay, so if we had f of x, and we know that that's equal to f of negative 7, right? So claiming that these two notations are the same, then that means that x must equal negative 7, right? So if x equals negative 7, this is where that substitution comes in, right? All right, so basically, another way of explaining this is with the transitive property, right? So if f of x and f of negative 7, right, while not really being the transitive property here, right, we don't have any equations or anything like that, then x, okay, must equal negative 7, and that's where you get this idea of substituting this negative 7 in, right? It's a notation. That's kind of where it's a play off of. So that's kind of what we're doing here. So let's just do a couple examples here. So I'll go through like a couple of these, but then from there, it's just a matter of going ahead and doing the work. So I'm going to jump down to, I think, a little bit of the harder ones, I would think, which means I'm going to worry about doing number 4, and I'll also do number 5, okay, and then I'll jump to another page here. So one of the most important things with substitution, always remember, substitution is using those parentheses. So this problem, number 4, says f of x equals x squared minus x, and then if find f of negative 4. So evaluate it for the given function. So essentially what I'm saying to you is that my input, okay, is equal to negative 4. So the way I write this is I rewrite f of x as saying, okay, we're going to use the f function with an input of negative 4. So using parentheses, negative 4 squared minus negative 4 in parentheses. So then we evaluate this, and negative 4 squared, remember when it's in parentheses like that, it becomes positive. So f of negative 4 equals positive 16. Minusing a negative becomes positive. So you get 16 plus 4. So f of negative 4 is equal to 20, right? So essentially, after you get past the notation piece, it's just back to stuff that we would have done in our chapter 1, which is just evaluating some functions here. So number 5, let's take a look at number 5, plugging f of 5 in. So f of 5, okay, so the function of f with 5 input is going to be equal to negative 1 times 5 squared plus 6 times 5 minus 4. Now remember, okay, this is literally like saying to you x equals 5, right, without writing it in that way. So we use substitution here, right? So this is where the substitution comes into play. So f of 5 is like saying, hey, x equals 5, so we go ahead and substitute it in. And that's all it is. There's nothing more than that. We just evaluate functions. That's all we do with them. Okay, there's a couple other things we can do with them. We can put them and other together, but most of the times when we're dealing with functions, we're going to just be evaluating them. So here we go. So f of 5, okay, evaluating this, 5 squared, that's what we do first. We get 25, so negative 1 times 25 plus 6 times 5 is 30 minus 4. So continuing on here, this is just negative 25, so I'm going to do some mental math. Negative 25 plus 30 is 5, and then 5 minus 4 is 1. So f of 5 equals 1, okay? And then that's it. So that's the problem. It's now done, right? Now, here's the other thing I want to point out to you, is that if I were doing this, okay, as a ordered pair, like if I were going to plot this point, okay, because inevitably the whole point of us evaluating functions is for input output. All right, I would literally say the ordered pair to this is the 0.5 comma 1, right? The input was 5, the output was 1. So it was a -1, or 5, 1 was the quartered pair that it'd be plotting. All right, so on to the next page. Okay, so next page here, right? So the next thing that I'm going to be doing here, right, is just a couple of other practice problems. And one of the practice problems I'm going to be doing here is number 9. And then I'm going to go into where we have these multiple, right, where I have these multiple functions. And that's the idea of where it enables me to work with multiple equations at once. So I'm going to give a couple examples here. So here are the examples, right? So it says f of x equals 4x plus 11, right? And then we have f of c plus 7. So we are able to plug expressions in. So in other words, what I'm going to do here is f of c plus 7 is the input. So wherever I see an x, I'm going to replace it with c plus 7, and then I will be adding 11 to it. Now, from here, I can do the distributive property, and I end up with this 4c plus 28 plus 11. And now we're just combining like terms, right? And what's weird about f of c plus 7 is just going to be the fact that, like, when combining like terms, I'm left with 4c plus 39. So unfortunately, it doesn't actually help me. It appears as though it doesn't really do anything for me, because essentially what I've done is I've taken one variable, okay, and its input was with another variable. So essentially, I'm not going to get to anything new. I'm just going to create basically a new rule type thing out of it. So that's what that problem does there. Number 10 is there for you to try to practice with, or if you should have questions. On to the next one, right? So the next one is the one where I really want to get into, where it's just evaluating, right? So we're going to use the functions on the left here. So we have f of x equals 8 minus 3x. We have g of x equals x squared plus 2x. And we've got h of x equals negative 5 over 2x minus 1. So these are the three functions that I have. And I'm just going to go ahead and I'm going to do two of these. So I'm going to start off with 11, and then I'm going to go ahead and jump into number 14. And then I will do number 15 as well as an example of one of these, okay? So here we go. So number 11, okay, it says f of 4 plus 9. So what it wants you to do is it wants you to find the value with an input of 4 in the f function and then add 9 to it. So in this particular case, f of 4 means that I'm going to come down here, okay, and I'm going to say 8 minus 3, so again, the f function, minus 3 times 4, and then I'm going to add 9 to that function. So notice that I'm taking f of x, which is over to the left, 8 minus 3x, and rewriting it as just 8 minus 3 times 4. And essentially what we've now done is we've created a new expression, and the new expression here is 8 minus 3 times 4 plus 9. So negative 3 times 4 is negative 12, and plus 9 there. 8 minus 12 is negative 4, and negative 4 plus 9 is equal to 5. So the final answer to this one is just 5. Number 14, right? So number 14 says 3 times h of 2 minus f of negative 9. So now what's really, really important here, right, is we are doing substitution. So when I place a minus in front of a substitution, remember that parentheses are extremely, extremely important. So this is going to be 3 times h of 2. So what I'm going to do is I'm going to go find the h function, and I'm going to plug in the entire h function. So substitute the entire h function with x being replaced with 2. Substitute the entire h function, okay? Substitute the entire h equation with a 2 in for x. So that's what I'm going to do. Take the entire h function, which is negative 5 over 2. Now replace the x with 2, so 2, minus 1. That's now plugged in. Then minus the entire f function with negative 9 plugged in. So in substituting in the entire f function, which is 8 minus 3, but instead of saying 8 minus 3x, I'm going to put a negative 9 in for that. And then from here, it's a matter of evaluating. So order of operations, parentheses first. So 3 times, well, negative 5, a halves times 2 is negative 5. So that's negative 5 minus 1, parentheses, minus, parentheses. So negative 3 times negative 9 is positive 27. So this becomes 8 plus 27. Still simplifying my parentheses here. So this becomes 3 times negative 6. Minus, now I can do minus, so 8 plus 27 is 35, so this is minus 35. And then last but not least, I have 3 times negative 6, which is negative 18, and negative 18 minus 35 equals negative 53. So the answer to 14 is negative 53. So the important part here is getting past the substitution piece, and once you're past that, you're good to go. All right, so just remember that I'm taking whatever equation that the letter, okay, matches with. All right, so H with H, F with F. All right, and then over here you would have G with G, right? Okay, so on to number 15. All right, in number 15, if I say f of x equals negative 13, and I want you to find x, what we're going to use here is the transitive property, right? So that's how we get through this problem. Okay, so if I have if f of x equals negative 13 and f of x equals 8 minus 3x, right, then, okay, then what has to be true here, right? So just the transitive property, then what has to be true is negative 13 has to be equal to 8 minus 3x. And now, essentially, what you have is you've created an equation, which now you can do the task of finding x. So it's a two-step equation, so I subtract 8 from both sides, subtract 8. I get negative 21 is equal to negative 3x. Do my inverse operation, divide by negative 3, divide by negative 3, and I get a value of x equaling 7. Okay, so that's it for today's notes on function notation. That should be enough now for you to go ahead and practice the homework. Oh, wait, sorry, I forgot one more. All right, so one more here, right? So we got to talk about 18 and 19 here. So, I'll do 18 so you can practice 19. So number 18, right? So number 18 is going to be playing off of this, right? It's going to be locating points from a graph. And locating points from a graph is, okay, so a couple things we need to remember. We need to remember that y equals f of x, right? And one of the things to note here is look over here on the y-axis, okay, highlighting here in red, okay, that it has on the y-axis, it has this f of x. And the reason for it is because y equals f of x. And then what also we need to remember is that that x represents the input, yes? So in this notation, right, what we're going to do is we're going to literally match, okay, what is the value on the graph? And remember, the graph is the drawing. So our drawing here is this little thing, okay, this little curve, okay? So we're going to figure out, okay, what is the point on the graph that matches with an x-coordinate of, in a few of these, okay, we have a couple of them. So what we're doing is playing the matching game. So what essentially I want to do here is I want to fill in the coordinate of x comma y, but in this equation, I'm already going to give you the x, okay? So essentially what this problem is simply saying to you is determine y given x, okay? Determine the coordinate knowing that its x-coordinate is given to you. So in number 18, what I'm going to do here is I'll take a look at this. I'm given that x is negative 3, so I go over to x equaling negative 3, and then I'm trying to find out what's the y-coordinate on this curve with an x value of negative 3. Well, the curve is here, which is up 2, so I would say f of negative 3 is equal to 2. In b, okay, so b is this f of 1, so what I'll do is I'll go to when x, okay, x equals 1, and then I will find out what the value of y is on the curve. So the value of y on the curve is a 2. So it's 2. The next thing I do is go to 0. So, right, f of 0. So go to when x is 0, which is at the origin, and then find out what the value of y is on the curve. So 1, 2, 3, 4, 5. So the value of y on the curve is 5. So equals 5. So again, this game is just a matter of playing the game. Determine the value of y given x that is on your curve or your graph. So f of 2. So what I'll do is I'll just go out to when x equals 2, and then I'll go down to find the curve. So not quite there, but boom, right there, which is a -3, and then I'm done. Okay, so what I would recommend is doing a couple more of these practice problems that are in here, maybe 19. If you have questions, be prepared to ask them tomorrow, and then we'll go from there.